So we have Emily. Emily Delaney is currently a systems engineer at Lockheed Martin with a background in both mechanical and systems engineering. She has been working at Lockheed Martin for 8 years and has supported several programs from missile defense to renewable energy technology to GPS monitoring systems. She has a true passion for her work in the engineering field and enjoys sharing her story in hopes to inspire others to pursue STEM related careers. Welcome, Emily.
Thank you, and happy to hear that there's a good population of women out there watching. That's really exciting. So a little bit about me. I'm currently working for Lockheed Martin RMS in Valley Forge, Pennsylvania, as a systems engineer on a GPS software development team. So surprising a little bit because of my background in mechanical and systems engineering, but nonetheless, that's where I am right now. So my education, I got my undergraduate degree from Clarkson University in mechanical engineering. And then while I was working at Lockheed, I got my master's in systems engineering from Cornell. So I put a lot of pictures on here because I'm not just an engineer. I do a lot of other things like running, biking, being outside. I'm pretty artistic, so that's a big hobby of mine, as well as traveling. And my husband and I are currently doing a lot of house projects. So the way I structured my presentation today, I kind of wanted to put into perspective some of the things that I was thinking about when I was a lot younger and kind of how that evolved into where I am today. 8 years into a career at Lockheed Martin. So, you know, when I was in high school, I didn't always know that I was going to be an engineer. I had a lot of interests. So I knew that math, science, and art were some of my favorite subjects, but that didn't necessarily mean I wanted to be an engineer yet. My dad was an engineer, but at the time I knew that and didn't really know what he did. So maybe some of you can relate to that as well. And then I was lucky enough to go to a summer engineering camp where we designed and built a toy for children with disabilities. So that was pretty awesome, and my kind of first taste of what it meant to be an engineer and make an impact on the world. So then I went to college and I studied mechanical engineering, and it was definitely challenging, but I really liked the challenge, and it seemed like a good fit for me. And like I mentioned, I really like art too. So the mechanical engineering was kind of a good blend of both technical and design aspects. So I was also taking some digital art courses to kind of improve my design skills and satisfy that interest. And then my summer internships were at a medical device company, and they were really great, mostly because they really helped me understand what it's like working in a business environment, things that you don't learn in school. So then right out of college, I started my career at Lockheed Martin. And this is where I was definitely nervous going to a big defense company right out of school, but I really liked solving problems and taking on new challenges, and actually being responsible for my own work. So that was pretty neat. And then, like you've seen in a lot of other presentations today, I'm sure Lockheed Martin is a huge company with such a variety of experiences and programs. So I was really interested in all that the company had to offer. So today I am going to focus on one program that I worked on that's very applicable to the STEM technology in terms of renewable energy. So I worked on a lot of different programs, but this is one that I'm pretty passionate about. So I spent several years working on the AR-1500 tidal turbine. So the tidal turbine is a 1.5 megawatt tidal turbine. So as a reference, that can generate energy for about 1,400 homes. And basically the concept is it's similar to a windmill, but sits on the bottom of the ocean floor and harnesses energy from the ocean tides. So it's currently deployed off the coast of northern Scotland. And this project was a project that Lockheed Martin partnered with a company in the UK called Atlantis Resources. And my role on the project was a mechanical engineer and also the assembly and test engineer. So a little bit about tidal energy. So like I said, it's basically a way to harness energy from the ocean tides. So the gravitational pull of the moon and the sun along with the Earth's rotation cause tides to occur. And they're actually very predictable. And you can predict not only when the tides occur, but also when storms occur. So you can be prepared for that up to 50 years in advance. So this, unlike wind and solar, it's a very reliable source of energy. And in parts of the world, there are really good spots for deploying these, which, the difference in a high and low tide can be up to 40 feet. So some of you might be used to seeing some of the low tide and high tide changes, but some of the areas in the world, they're very, very drastic, meaning you can harness even more energy. So tidal energy technology systems, they convert the changing in the tides into electricity that can be used to power cities and homes. And this picture I really like because it shows that there's not one solution to this problem. There's actually many, and many that are still being developed. So it's a pretty neat area. So all the way to the right is a little cartoon of the project that I worked on, but there are obviously lots of other ways that you can harness tidal energy. All right, so how do tidal turbines work? This is a cartoon drawing of the turbine that I worked on, and there's basically a gravity-based foundation that's pre-deployed on the ocean floor that the rest of the turbine gets deployed to at a later time. So that's kind of pre-established in place with all the offshore cabling connected to the electrical substation onshore. So in terms of how you collect the energy, the tidal currents are what cause the blades to rotate, and that spins a shaft in the turbine, powering a generator to produce the electricity. And like I mentioned, the undersea cables are what connect the turbine on the ocean floor all the way to shore. And there's an onshore electrical substation, which is connected to, in this case, the national grid in Scotland. And then you can deliver electricity to people all over the country. So these are just highlighting some of the main components of the turbine. I specifically worked on the variable pitch system. So that allows you to control the pitch angle of the blades. So you can always maintain an optimal power generation. And then the blades are what actually, are used to turn the turbine and the low speed shaft so that the generator can produce the electricity. And then another major component that Lockheed Martin was a part of was the yaw drive system. So because the tides go in and out and change directions, the yaw drive can rotate the turbine 180 degrees. So for those of you who have not started, thinking about what you want to do, I just wanted to show that when I started this program, this is what my computer screen looked like. I didn't know anything about tidal turbines before. I was a mechanical engineer, but I had a lot of learning to do, and I didn't have an existing design to work from. So there was a pretty big learning curve, but I found that to be like one of the most exciting parts. So then I started getting involved in the design and doing a lot of research on how either similar technologies that are out there like wind turbines or propulsion systems, and then doing a lot of 3D modeling and drawings for the actual assembly. And then this is a picture of the turbine actually being assembled. So like I said, I was a big part of the assembly and test. So it was really, really cool to see my all the designs that I had done in the computer were actually coming to reality. So that was really, really cool. And then this is the final assembly right before it gets deployed. So a pretty cool moment to see it all come together and go out for the first time. And this is probably my favorite picture. Like I said, this was, deployed off the coast of Scotland. So unfortunately, I wasn't able to be on the ship when it was deployed, but these pictures kind of really show all the hard work that our team put into the project. So it was really neat to see that it was actually going to come to reality. And so what is the tidal turbine doing now? As you could kind of tell, the years that I worked on the program were several years ago now, but I'm happy to say that it's still in the ocean, harnessing energy for the people in Scotland. So there actually are 4 turbines that are currently deployed. One that was, our turbine developed by Lockheed Martin and our partner company in the UK, and 3 that were built by another competing company. And then today there actually still are efforts to further, advance the technology to turbines that can harness even more energy, and kind of trying to optimize some of the main technologies, and how the actual, using the turbines to harness the energy has to be an efficient use and cost effective, so that people actually want to keep deploying them. So there's a lot of work to be done there still, I believe. But this picture, you can kind of tell in the middle there how actually big the turbine is compared to the people that are standing right by the trailer. So it's quite large, but much smaller than a wind turbine. So just for reference, these blades are 20 meters. This has a 20-meter diameter. And for wind turbines, they're typically like 80 to 100 meters. So a lot smaller due to the density of water, but still pretty big.
Some students want to know what is the tidal turbines made of, like what material, because they don't seem to rust.
Oh, so for rust, yeah. The turbine blades are a composite material, but most of the main turbine is steel that's coated with a special paint that deters rust and marine life growth. So they're protected from any ocean life kind of growing on the turbines.
And the next question is about ocean life. How do we prevent turbine from hurting like sea turtles and other ocean life?
I get this question every single time. So I was not part of this, but there was a team that actually did a lot of research in the areas that the turbines are deployed. And first of all, not only was there research done ahead of time, but the turbines that are deployed in areas where the changing of the tides is so extreme that it's actually not a typically habitable area for a lot of marine life. So there's maybe it's just not there's not a lot of fish swimming around there, but they're pretty big. And while they're big and they do move, I have not heard any stories of hurting too many marine life, but it's definitely a concern that there's been studies on for sure.
This is interesting. Is there only one of the AR-1500 turbines you made, or is there many other AR-1500 turbines in different parts of the world?
Yeah, so that's a great question. This was a first in class, never been built before unit, and we built one of them. Our partner company in the UK kind of took over the program for Lockheed after we finished this one, and they've since been working to build more turbines. So I think that the tidal turbine industry is, kind of at its infancy still, and there's, years and years of development, like I said, to optimize and make sure that this is a cost-effective way to actually generate energy.
Thank you, Emily, for such a wonderful conclusion to our morning section.
Thank you.